Greetings, this is Dr. McGuire, and this is a screencast, the first screencast for Chapter 15, Correlation. The goals for this screencast are as follows. We want to cover the first section of Chapter 15, 15.1, Introduction to Correlation. And there's only one learning objective in this chapter. Describe information provided by the sign, plus or minus, and the numerical value of a correlation. And then in addition to that, given that there wasn't, since there was only one learning objective, I thought we might be able to squeeze in how to interpret scatter plots, because that's discussed in the book, as well as how to create scatter plots in both Excel and SPSS. So let's get started. All right. Correlations. What is a correlation? It comes from the word correlation, so the relationship between something, and in this case it is the relationship between two variables. And the way we note whether there's a relationship is to see how one variable changes in terms of the other variable. So a relationship exists when changes in one variable tend to be accompanied by consistent and predictable changes in the other variable. And this is a sample of data from the textbook, figure 15.2, which I'm going to come back to later. But this is showing us the relationship between two variables. One variable is family income, and the other variable is students' average grade. And the idea here is to see whether there's a relationship and what that relationship is. In other words, will we see increasing grades as family income increases? The other thing we see here is that we have a sample of 14 people, and so for each person they're getting measured on two variables. So that's another thing to keep in mind when we're dealing with correlations. We always have two data points per entity that we're observing, in this case people. The other thing to point out is there's an interesting, the previews to the chapters are kind of neat because they pull from actual research, and that was kind of interesting if you didn't get a chance to see that or review the income and weight for men and income and weight for women. All right, we can take away from a correlation three aspects of the relationship. First, we can take away what the direction of the relationship is. So, for example, if there was a relationship such that with increased income we saw higher grades, we would call that a positive relationship. So as you increase on one variable, you see an increase in the other variable. So in this case, it would be increase in income, typically have higher grades. In a negative relationship, you see the exact opposite. So as you go up on one variable, you go down on the other variable. So an example here might be coffee sales and month or temperature. So I'm thinking that in the hotter months, typically you might see a drop in coffee sales compared to the cooler months. So probably temperature outside would be a better example here, because then we have a numerical variable. As temperature increases, what happens to coffee sales? Probably would see a drop in that. So there's a negative relationship there. And here is a reference to hypothetical data based on an actual study. So this is looking at the income. Let's see, let me move this a little bit. So what is the annual income for men in thousands of dollars, and what's their weight? And here we see a positive relationship between income and weight. So as an individual's income increases, they typically are weighing heavier. Now there's a difference for women though. So in this case, as we see an increase in income, we see a drop in weight. And again, this is based on the study that's cited at the beginning of the chapter. The study's by Judge and Cable, 2011. And Again, so this is based on that study. We see with income and weight for women, this is a negative relationship, this is a positive relationship. And really, if there's not a line in the scatter plot, these are called scatter plots, then you could come up with an imaginary line and see, does the line go up? If so, it's a positive relationship. Does it go down? If so, then it's a negative relationship. Now, if it doesn't appear to be any direction, then there is no relationship. And sometimes that's totally feasible, that there is not a relationship between two variables. All right, so the next, oops, went too far. The next thing to discuss is the form. So we just got done talking about the direction. Now let's talk about the form. The most common use of a correlation is to measure straight line relationships, and that's because this is similar to some of the statistical tests we've been talking about. It's based on the general linear model. Now there are other types of relationships that exist, and you have to use special correlations to measure them. So there could be curvilinear relationships, and so that's something to keep in mind. But that's going to be based on a different type of model than what we are typically using or referring to in this book. So in addition to the form, we can also talk about the strength. Now this trips up some students. You don't want to look at the specific value. Well, I mean you do. The bigger the value, the stronger the relationship. But it goes in both directions. So for example, if you had a correlation coefficient of negative 67.67 and you had a positive correlation of 0.43, which one would be the stronger of the two correlations? Well, you have to take the absolute value, negative 67, negative 0.67, take the absolute value of that and you get 0.67, so that would be the stronger of the two. So anyway, the strength. The correlation measures the consistency of the relationship. And here are some examples. So in this first graph here, whoops, let me do that again. Okay, in the first graph, we see a perfect negative linear relationship, and that would be the strongest of all of these relationships between two variables. Here, what you would do is, again, try to imagine drawing a line through this oval, and if it's shaped like a football, chances are there's going to be a correlation or some indication of a relationship. But here, the line, there's no direction. I mean, there's no relationship, so chances are this correlation would be a 0. And then in this correlation right here, we see this looks more like a football, so this is going to be chances are we're going to have a relationship there, and it's positive, because if we were to draw a line, let me change what I'm using to draw with. If we were to draw a line through this, and it's upwards, right? So as you increase values on X, you see increasing values on Y. And here, this is there is a relationship. If we were to cut this oval in half, we would see a downwards line. So this is another negative relationship. As we go up on the x-axis, we drop on the y-axis. Okay, so now let's talk about creating scatter plots in Excel and SPSS. To do this, let me turn our attention over to this Excel file. And this is in Chapter 15, Figure 14.2. And all you have to do, so I've entered in the data. Now I've added one column, this end column. What I've done here is, again, like I said, just enter in the data. What I need to do next to create a scatter plot to get an idea of how these variables relate to one another is I have to go, well, I have to select what I want to create a scatter plot of. And then I go to Insert, and then I go to my charts. Actually, this one right here says Insert Scatter XY or Bubble Chart. I'm going to create a scatter plot. And there's my scatter plot of these lines, the X lines and the Y lines. We just want a primary X axis and Y axis. If you look at the scatter plot that they provide for you of this data in the text, then they truncate the X axis and the Y axis, so they make it look a little bit more extreme than what it really is. Anyway, so that is how you would create a scatter plot in Excel. It's pretty straightforward. Now if you were to put this, if you were to write up your research and you wanted to include a scatter plot in your write-up, you would have to make sure you have a Y-axis, an X-axis. You would get rid of this for sure. And I can show you how to put labels in at a later point in time. You can also Google it as well. I mean, there are a lot of cool videos on how to do things in Excel. Anyway, let's do this in SPSS real quickly. And the first thing you have to do is let's copy our data, and then I have SPSS ready to go in data view. And one of the things that we need to do is let's label our data, and our X variable, our first variable, was family income. I'll just say income here. And then our second variable was grade. Actually, it was student's average grade. The other thing I need to do is change these to scale, the measures to scale. Alright, I'm back in data view, and my next step is to click on the graph chart builder. If you have gone ahead and defined your variables, you should be good, which we did. And I need to come down to the scatter dot. I need to double click that. And when you do that, you'll see this. This was already selected. I think maybe it would have been on bar by default, but click on scatter dot. Then you have to move your variables into the appropriate axis. Well, let's just stick with what they have in the book, and the student's grade is on the y-axis, and then on the x-axis we have income. And that is it. All I have to do is click, let me move this window a little bit, you just click OK next. Now you'll see a scatter plot, and here we go. Let me move this so you can see that. Again, this comes out pretty ugly. I don't know if it's, I don't know which one is worse, SPSS scatter plot or Excel's. But one of the things is we have our axes already labeled for us, and we get a different view. Now if we look at this, it looks like there's a significant positive relationship here, but again, some of this y-axis doesn't start at 0. And if you read the APA manual, typically they recommend that you use the range of your data. So if your correlation, or if you could have a value of 0, then you probably ought to include that. Anyway, so this is how you create a scatter plot in SPSS. Alright, that is it, and until next time. Well, next time what we'll talk about is how do you calculate a correlation coefficient. So until then, have a good one. This is Dr. McGuire.